Hello, AI enthusiasts. Welcome to Chapter 3 of this course. Let us continue our discussion on AI core concepts. In this chapter, we'll continue our discussion of machine learning and get familiar with deep learning. We'll also find differences between machine learning and deep learning. Let us try to answer an exciting quiz here, a regular series. We have input-output pairs like this. Say, output 32 corresponds to input 0. Output 46.4 corresponds to input 8, and so on. The question here is, what is the output of input 38? Please give it a serious thought for a while and see if you can answer this question. Have you found the answer? Luckily, it's not the answer I'm looking for. Instead, I was hoping you could think very closely about how your brain was trying to solve this problem. Your brain was trying hard to find a pattern among the input and output numbers. It was trying to find a formula from known input-output pair. Well, that's, in a nutshell, how machine learning works. Finding patterns or some inner meaning or formula from a given input-output pair. By the way, the answer is 100.4. That is the Celsius to Fahrenheit conversion formula in play. I would not judge you if you got it wrong. Now, let us try to understand another interesting question. We know that we all have our own standards and definition of beauty, and we can immediately distinguish someone as handsome or beautiful upon seeing them. But do you think AI can judge beauty generally as we do? Can it find beauty from given photos of people? If so, how? We will try to understand that with another example. As we know, machine learning analyzes and mines valuable information, knowledge, trends, and patterns from big data. A larger amount of relevant and clean data usually results in a more accurate trained model. With machine learning, programmers no longer have to write all the algorithmic steps and rules. The software can find rules from big data. Therefore, for our beauty problem, we need to train an AI model with labeled data. For that, we need a dataset like this, where we have many human photos as input and the labels such as beautiful or average as the output, just like that input-output pair we're working on previously. Then, after observing our dataset professionally, we select some machine learning or deep learning algorithms or models and feed this dataset. The task of the selected model would be to find patterns and correlations among these input-output pairs. The model would try to find out the answer to the very question, why on earth did my master, human, label this particular picture as beautiful, but not that one? Is it the shape, symmetry, edges, size, color, or any other features that made this picture beautiful? That's the answer our model will find by adjusting various mathematical parameters. After iterating through this statistical analysis and training process, Our model is finally trained. Now it's time to see how it works. We input a new photo, being curious, and the trained model says the probability of this new input image being beautiful is, for instance, 89.4586%, or it falls in the beautiful class. In a nutshell, that is how machine learning works. I hope this concept is much clearer now. If so, I have another question for you. Can we think of a model as some n-dimensional function? Let's give it a thought. Next, let's explore the types of machine learning. There are mainly three types of machine learning broadly used today. Number one is supervised learning. Number two, unsupervised learning. And number three is reinforcement learning. In supervised learning, we are given a labeled dataset and already know what our correct output should look like. In other words, the correct answer is known. Here, we assume there is a relationship between the input and output. Moreover, the goal is to find that relationship or the formula. Supervised learning problems are categorized into regression type and classification type problems. In a regression problem, we are trying to predict results within a continuous output, meaning that we are trying to map input variables to some continuous function. In a classification problem, we are instead trying to predict results in a discrete output. In other words, we are trying to map input variables into discrete categories. Unsupervised learning allows us to approach problems with little or no idea of what our results should look like. We can derive structure from data where we need to know the effects of the variables. We can derive this structure by clustering the data based on relationships or similarities among the variables in the data. Clustering or grouping is the unsupervised type of problem. Reinforcement learning is to act based on feedback or reward and punishment mechanism. The other types of machine learning problems would be anomaly detection, sequence labeling, and recommendation type of problems. Let's explore these concepts with simple examples. Suppose we have pictures of cats and the labels, which are, of course, the name cat. After training our model with labeled cat pictures, we can expect our trained model to identify cats and not cats from an unknown given input of cats and other animals. That means supervised learning needs a labeled dataset. In practice, we can use the logistic regression algorithm or support vector machine algorithm to solve classification type problems. We can use the linear regression algorithm to solve regression type problems. These all belong to supervised machine learning. On the other hand, unsupervised learning works on a bunch of data without any label or tag. Furthermore, various unsupervised learning algorithms extract different clusters or groups from the given unlabeled dataset. For example, if you have a dataset of different animals, say cats and dogs, the clustering algorithm can distinguish two groups or clusters based on the similarity among cats and similarity among dogs, without telling us which one is a dog and which one is a cat. There is no comprehensively superior algorithm in AI. Various algorithms such as SVM, AdaBoost, random forest, and neural network play an essential role in different fields. Reinforcement learning is, if you do it right, you'll be rewarded. For example, in a circus, you are trying to train some exotic animals like tigers. You want the tigers to sit down on your command. So first, you try to establish the command to sit down by saying so or showing the move. If the tiger sits down, you reward it with meat. But if it does not listen to you, you might use your electric whip as punishment. So, over time, you may get your tigers trained throughout such training, right? In our machine learning scenario, our robots or intelligent agents take actions. Say, they try to find the right path out of a maze. A reinforcement learning algorithm assigns some positive value if the robot takes the right step. If the robot takes a wrong step, some negative value is assigned as punishment. In this way, the robot tries to maximize its reward or positive value and eventually learns to find the right path. We can compare reinforcement learning with how parents try to teach their children. So far, we have talked about machine learning. Machine learning refers to the use of algorithms to enable computers to extract information from data as humans do. Now, let us briefly explore the concept of deep learning. Generally, the deep learning architecture is a deep neural network. The word deep in the deep learning refers to the number of neural network layers. The network is built by simulating the human neural network, which is connected through layers. In designing and applying artificial neural networks, the following factors need to be considered: neuron functions, connection modes among neurons, activation functions, and network learning or training. Currently, the definition of the neural network has not been determined yet. H. Nelson, a neural network researcher in the US, defines a neural network as a computer system composed of simple and highly interconnected processing elements, which process information by the dynamic response to external inputs. A neural network can be simply expressed as an information processing system designed to imitate the human brain structure and functions based on its source, features, and explanations. We can think about a single neuron as a simple information storage mechanism. It can simply hold a number or a function. A single neuron architecture is called a perceptron. It has so many limitations. But the multi-layer perceptron is a feed-forward neural network. It is the simplest neural network with neurons arranged in layers. Generally, there is an input layer, an output layer, and one or multiple hidden layers in a neural network. Input nodes do not have the calculation capability and are only used to represent element values of their input vector. The neuron having the computing capability at each layer is referred to as the computing unit. Each neuron is connected only to the neurons of the previous layer. A unidirectional multi-layer structure is used to receive the output of the previous layer and send the output to the next layer. Each layer includes several neurons, and the neurons in the same layer are not connected. Only unidirectional interlayer information transmission is supported. Let's find out the difference between machine learning and deep learning. Traditional machine learning is a step-by-step process. The optimal solution at each step only sometimes results in an optimal solution to the results. On the other hand, the manual selection of features or feature extraction, which we need in machine learning, is a time-consuming and laborious method. It requires AI expertise and industry insight and is largely dependent on experience and luck. Deep learning, starting from the original features, automatically learns advanced feature combinations without manual feature extraction. The entire process is end-to-end, and direct assurance is that the final output is the optimal solution. However, the hidden layer in the middle is like a black box. We do not know what feature the machine extracted and why. Now, when should we use machine learning techniques, and in what scenarios should we go for deep learning? Here we have some simple indicators or rules of thumb. We can go for machine learning when feature engineering is not complex. But if feature engineering is hard, we may consider deep learning. Machine learning can learn from a comparatively smaller dataset, but deep learning algorithm needs a bigger dataset. If we have limited computing resources, we should use machine learning. On the other hand, we need better computing resources such as GPU for deep learning. If we are looking for simple and explainable solutions, we should bet on machine learning instead of deep learning. Finally, if we can meet our business goals with medium accuracy of the trained model, we can use machine learning. But if we expect higher accuracy in most cases, we might need deep learning. Now it's quick quiz time. Question 1. What are the main types of machine learning? A. Weak ML, strong ML, and super ML. B. Supervised ML, unsupervised ML, and reinforcement ML. C. Digital ML, analog ML, and hybrid ML. Or D. Linear ML, polynomial ML, and hyperbolic ML. Question 2. Which of the following are the differences between ML and DL? Note, there are multiple answers to this question. A. ML requires manual feature engineering, whereas DL does not. B. ML trained models are explainable, whereas DL models are not. C. ML requires more data, whereas DL needs less data. And D. ML models are more beautiful than DL models. Please pause this video now. Think about these two quizzes and try them yourself first. Well, the answer to question 1 is B. Supervised, unsupervised, and reinforcement type of machine learning that we discussed in this chapter. The answers to the second question are A and B. Answer C is just opposite to the truth. And option D is for fun. I hope you have got your answers correct. Let's now summarize Chapter 3. Machine learning and deep learning are the core of today's AI. These learning techniques make AI as smart as it is today. Learning algorithms perform diverse statistical analysis on data and find patterns from given input-output pairs. There are mainly 3 types of machine learning: supervised, unsupervised, and reinforcement learning. Deep learning is a subset of machine learning that mimics the way human brain cells or neurons work to make decisions. That's all for this Chapter 3. I'll see you in Chapter 4. Happy and smart learning.